Okay, calculate the pH of 0.7 molar NaC2H3O2. And then we have a Ka of 1.8 times 10 to the negative 5. First of all, let's make a prediction. What do you think the pH is going to be? Greater than, less than, or equal to 7? Greater than 7. All right, so I see that this is not a strong acid or base. It's not a weak acid or base. It is a salt. So the first thing I'm going to do is I'm going to drop my spectator and I'm going to put the anion in a rice table. I'm going to add it to water. So there's our rice table. Initially, we have 0.7 molar of our anion. Water is out of there. No hydroxide. No C2H3O2. Our change is minus X plus X plus X. And then we have 0.7 minus X. X is negligible. X and X. All right, so now we can go in and solve for X, but our problem is they've given us Ka, and we are working in a basic solution. So we need to know what Kb is. So first of all, Kb is equal to our hydroxide concentration times our C2H3O2 concentration over C2H3O2.
What's the difference between, Ka is an acid, Kb is base, right?
Yes. So to get to Kb, then we need to take Kw, which is, so Kw over Ka is equal to Kb. So Kw is 1 times 10 to the negative 14 over 1.8 times 10 to the negative 5 is equal to x squared over 0.7. So let's solve for x and put what x is, because we'll forget by the time we get there. X is our hydroxide concentration.
Is Kw always 1?
Yes, Kw is a constant.
Can we go cross multiply?
Huh?
Can we cross multiply?
It's either way you want to do.
1.972 times 10 to the minus.
1.972 times 10 to the negative 5th molarity for my hydroxide. And our question didn't ask for that. Our question asked for the pH. So if we take that, negative log of that, our pH should be 4.705.
Wait, our pH or pOH?
It asks for pH, but we need to find the pOH first.
Okay.
And pH, therefore, ends up being 9.295.
Wait a second.
Wait,
How do you?
75
I understand everything else, but what should that be 1.10?
The 1 point what?
I mean, I'm sorry, 1 times 10.
That's the Kw is always.
Oh, so
Yes.
it's always.
Yeah.
I accidentally did that.
Yes.
I have 2 questions. One is why we exit out in A.
It's a spectator
How do we know it's a
because it comes from a strong base.
I know. Are we assuming it came from like NaCl?
NaOH. Remember, acid, strong base, or weak acid, strong base. Strong acid, weak base.
What's the significance of guessing if the pH is greater than 7?
Oh, yeah, why do we have to guess?
Why? Just to see if I'm going to be right. Just.
And what does the base sign
I
off
don't know
of?
how you still guess.
How did I guess that off? Na, what's the parent of Na? Talking about acids and bases. What did Na come from? NaOH, which is a strong base.
So it would be greater than 7.
And this came from acetic acid, which is a weak base. Or weak acid, yes, sorry.
So the stronger base wins out.
So the stronger base wins out. Okay, let's see. Let's do the next one. We're not going to do this one. We're going to do B, but I'm going to move my arrow up here so I have room. So B is NH4Cl. So first of all, what do you think the pH is going to be? Greater than, equal to, or less than 7? Less than 7. All right. So Cl is our strong, so it is a spectator. So take NH4 plus and add it to water. And what two things do we get? H3O and NH3. Our initial concentration is 0.777, 0 and 0. Change is minus X plus X plus X. And at equilibrium, we are 0.777. X is negligible, X and X.
Why you can't see a lot?
Because it's a spectator. When I take HCl and I add it to water, it's going to break up into H ions and Cl ions. It's not going to want to come back together with HCl because it's so strong. Yeah, 100% dissociates. It's not going to come back together. So it's just a spectator out there, not doing anything. All right, so this Kb, so the Kb for NH3 is 1.8 times 10 to the minus 5th.
And you would have gotten that off of the chart.
I would have gotten that off a table. All right, so Ka, we are dealing with an acid, H3O plus. So Ka is equal to H3O plus times NH3 over NH4 plus.
Do we have to wrap that up to be
You don't have to. I mean, unless I ask you to. I just do it to know where I'm at. So Ka, that's awesome, but I don't have a Ka. They've given me a Kb. So now I need to take my water, Kw, 1 times 10 to the negative 14, and divide it by the Kb that they've given me, 1.8 times 10 to the negative 5, is equal to x squared over 0.777. Get me a value for x, which is going to be H3O plus. Okay, so I'm going to put 2.08 times 10 to the negative 5th molarity. That's our H3O plus. So what is our pH? The negative log of that, yes. So 4.682. Any questions? On your test, I'll pretty much guarantee you'll have a hydrolysis, you'll have a strong acid, you'll have One of all of these. You always do on your test. All these problems we ever go through, you all have one of them on your test for your free response. Yes.
With the hydrolysis, all they're doing, or is this part, is that what we did just the mathematical part of the hydrolysis, or the problems before it? Because it just kind of broke the equations down. We didn't really do anything.
Where at?
12, 13.
Yeah, that's just predicting what would be happen. Yeah, that's not
So
the
15 is
is
like the math.
the math. Actually figuring out what the pH is, rather than just writing dissociation problems. All right, for this next one, tell me, what's the pH of this going to be? Greater than, equal to, or less than
Neutral.
7? Neutral. 7. Good.
Okay, but how do we
Oh,
know
we
it's
wrote that
neutral?
down.
Yeah, we wrote
Oh. K comes from KOH.
Oh yeah.
Cl comes from HCl. And they dissociate 100%. So pH would be 7. This one, I'm not going to do this, but if you want to, you can go back and solve for it. The Ka would be H for HC2C3O2 is 1.8 times 10 to the negative 5. And your end answer should be 9.179. So you should want to go and do that. Any questions on that? So now what we're going to do is we're going to put these into polyprotic acids and polyprotic hydrolysis. So all a polyprotic acid is an acid that contains more than one ionizable proton. So it has more than one H. So if I had H2A, H2A is going to dissociate into H plus and HA. HA still has some H there that it can give away. So it will further dissociate into H plus and HA with a 2 minus. The most important thing to know is that after that first proton is lost,
Is A just a variable?
A is just acid.
Okay.
After the first proton is lost, the second proton is mathematically negligible. What's that mean? When I lose that second proton, it's not going to affect the pH. And these all have values. This one would have a Ka value, and that would be our first dissociation. This one would have a Ka value, and that would be our second dissociation.
And let's say if we had it, 3 hydrogens with those 2 anthranes mathematically equal.
Yes. Okay. So let's write this. Let's do some of these. When we're doing them as salts, you need to know that some of them will be amphoteric, which means what?
It means there's one
Acid
acid and base.
Acts as an acid and base. So depending on which K value is larger, depends on whether it's going to do act as an acid or base. So if we're looking at this H2PO4 and I add it to water, it can become H2PO4 minus, or it can become H3PO4. Which one is it going to be? Well, I go and I look at my K values, and I find the one that is larger, and that is the one that is going to occur.
What?
So the Ka values, you find the Ka values, the Ka value that is larger is the one that is going to occur. So if I look at this one's going to act more as an acid than it is as a base because of that Ka value. Okay. So first problem, carbonic acid is diprotic. write the two dissociation reactions, so showing its diprotic behavior. So first of all, H2CO3. I can add it to water, and naming one thing that it will become. H3O plus and HCO3 minus. HCO3 minus, can we still lose an H? Yes, and it's going to lose one, and when it does, we are going to get H3O and CO3 2 minus. Everybody good with that?
And the reason it's because it said it was acid. Oh, it's not salt. Never mind.
All right, if the initial concentration is 0.1 molar, calculate the H plus. Assume the first dissociation occurs. So we go back up here. This is equation 1. This is equation 2. So first dissociation, which is equation 1, is what is going to occur. So let's go ahead and put that into our rice table. So H2CO3 plus water, and we get HCO3 minus plus H3O plus. Initially, we have 0.1 molar. Our change is minus X plus X plus X. At equilibrium, we have 0.1 minus X, X, and X. Is that X negligible? Yes. Let's go ahead and just say X is negligible. So now, it's given us the Ka. So we have Ka, so 4.3 times 10 to the minus 7 is equal to X squared over 0.1. 4.3 times 10 to the minus 8 is equal to X squared. So what's the value of X? .07 times 10 to the -4. That's my molarity of my H3O plus. So what is pH? Negative log of that. So 3 something, 3.68 is our pH. Yes.
Will they ever give us like Ka2 or Ka1?
It'll give you Ka1, Ka2, Ka3, and you've got to figure out which Ka you need.
But it will never, like, from K to figure out K.
No. Okay, everybody good with this? All right. Now I'm going to prove to you that this is negligible. So we're going to grab our second equation from the last page, which is HCO3 minus plus H2O gives me CO3 minus 2 plus H3O plus. When we ended up last, what was our initial, what's our concentration of HCO3 in our last problem? What was X in our last problem? 2.07 times 10 to the negative 4. That's our HCO3 minus, and that is also our H3O plus. So 2.07 times 10 to the minus 4. Huh? Because this is stepwise.
Why is it also the H2?
Because if you go back to that last problem, and I can't, it's gone now for me. When you go back to that last problem when we solved for X, that was for HCO3 minus and H3O plus. That's your initial concentrations of how much you're starting in there.
Oh, okay, I understand those ones too.
We're building on, yeah. Right. Now our change is minus X plus X plus X. 2.07 times 10 to the minus 4 minus X, negligible X. 2.07 times 10 to the minus 4 plus X.